Dzień dobry Państwu.
Good day.
W odcinku trzecim rozpocząłem omawianie wzajemnych.
In episode 3, I started discussing the interaction between matter. Let me remind you that the structure of a neutron and proton, as well as the formation of a gravitational and electrostatic field, are discussed. Today I will continue this topic. First, let's analyze how a proton and a neutron are joined, that is, two nucleons. Let us recall what the surface of a proton and neutron look like according to NTS.
Przypomnijmy, jak wygląda powierzchnia protonu i neutronu według NTS. Cechą charakterystyczną tej powierzchni jest
A characteristic feature of this surface is the alternating presence of electrons and positrons. Let us draw a simplified model of these nucleons. To make the drawing clearer, the lines of gravitational forces have been shortened to the length of two photons in the lines of compressive forces have not been drawn. According to the conducted experiments, bringing nucleons closer to each other as a function of energy will have the following course.
do siebie funkcji energii będzie miało taki oto przebieg. Z wykresu tego widać, że początkowo nukleony będą się odpychały, a od pewnego momentu będą się przyciągały. Jak to zjawisko jest tłumaczone przez współczesną fizykę? Przy tak małych odległościach jest to zakres tak zwanych oddziaływań silnych, których mechanizmu fizycy nie są w stanie.
It can be seen from this diagram that initially the nucleons will repel each other, and from a certain point they will attract each other. How is this phenomenon explained by modern physics? At such small distances, this is the range of the so-called strong interactions, the mechanism of which physicists are unable to explain. The strong interaction is all the more puzzling for modern physicists, as the force in separating nucleons from each other, up to a certain distance, is incremental. When discussing the fusion of nucleons, it is impossible not to mention the so-called mass deficit. According to our experiments, the mass of the joined nucleons is less than the sum of the masses. This phenomenon is explained by the supporters of Einstein's theory by converting the difference in mass, i.e. delta M, into energy. According to the most famous formula, E equals mc2, where energy can arise from mass. Such an argument not only contradicts Newton's teaching, but also appears to be illogical.
A jak to samo zjawisko, czyli łączenia się nukleonów, opisuje nowa teoria światła? Przede wszystkim, jak wyjaśniono wcześniej, w oddziaływaniach pomiędzy materią występują tylko siły elektrostatyczne i sprzężone z nimi siły magnetyczne. Siły, które określane są jako oddziaływania silne, oddziaływania słabe, czy też grawitacyjne, są siłami elektrostatycznymi, pełniącymi różne...
And how is the new theory of light describe the same phenomenon, i.e. the merging of nucleons? First of all, as explained earlier, in interactions between matter, there are only electrostatic forces and the coupled magnetic forces, the forces that are defined as strong interactions. Weak interactions, or the forces of gravity, are electrostatic forces performing various functions. The attraction power of two bodies charged with different electric charges is expressed Coulomb's law, which can be written as F equals kq1 q2 r2, where F, electrostatic force, K, electrostatic constant, q1 and q2 electric charges are distance between charges if the numerator of the formula. Assuming the invariability of electrostatic charges we treat as a constant value, we can assume that kq1 q2 equals A. We can now write the function f equals f, r equals r2. Let's plot this relationship on the graph.
Z wykresu widzimy, że jeżeli przy łączeniu nukleonów nie przekraczamy kilku femtometrów, przypominam to 10 do minus 15 metra, to siła F będzie bardzo duża. W skrajnym przypadku, gdyby R dążyło do zera, to siła F dążyłaby do nieskończenie wielkiej.
We can see from the diagram that if we do not exceed a few femtometers, 1 by 10 minus 15 meters, when joining nucleons, the F force will be very high. In the extreme case, if R approached zero, the force F would tend to infinitely great. Let us watch a simplified animation of combining a proton with a neutron. In the animation we can see that already in the phase of direct contact of the nucleons, surface positrons, red, and electrons, blue, quite accurately match. This results in a very tight association of nucleons. Both chains of photons, known as gravitational forces, as well as chains constituting compressive forces, surface nucleons, which are extremely advantageous in relation to the chains of gravitational forces, take part in connecting. Attempting to disconnect the nucleons will stretch the photonus chains, and as these chains are stretched, it will grow until it ruptures and then shrink rapidly. The precisely described phenomenon is confirmed by laboratory tests, and these are not some undefined strong interactions but under specific conditions, electrostatic interactions. The second issue that the new theory of light clearly and transparently solves is the so-called mass deficit.
Na animacji pokazano, że cała nadwyżka fotonusów, które nie znalazły swojego miejsca przy łączeniu nukleonów, zostaje wydalona na zewnątrz, uzyskując bardzo wysoką energię i tym samym zamieniając się w wysokoenergetyczne fotony.
The animation shows that the entire surplus of photons, which did not find their place when combining nucleons, is expelled to the outside, gaining very high energy and thus turning into high-energy photons. How the photons in an atom are converted into photons I will discuss later parts. So here we have a clear answer. What exactly is mass deficit? There is simply no such thing as a mass deficit in NTW. The mass balance before the fusion of nucleons is the same as after the fusion. If we take into account a mass of mass excreted with a specific energy of photons converted into high-energy photons. I hope that problems such as the so-called strong interaction and the so-called the mass deficit was clearly explained with the help of Coulomb's law and Newton's laws of dynamics, without resorting to miracles like mass to energy or some extraordinary atomic forces. Another topic I would like to discuss is the position of the electron in the atom. The history of the structure of the atom, and especially the role of the electron in it, has undergone successive evolutions because experience has shown deficiencies in the models adopted in succession. Currently, it has been assumed in physics that electrons revolve around the atomic nucleus in the described orbits according to the so-called quantum model. So let's see how the new theory of light explains this. Let us recall the proton structure described earlier. We know from the descriptions that in a proton, the positive electric charge is not distributed over the entire surface but occurs only between two positrons lying next to each other, creating the so-called electrostatic field force lines window. If we made the cross-section with the plane perpendicular to these lines of force, we would obtain the shape of the flux of the force lines of this field, as shown in the figure. This shape will be very important when discussing the vibrations of atoms in the crystal.
Ten kształt będzie bardzo ważny przy omawianiu drgań atomów kryształów. Dalsze wyjaśnianie przeprowadzę w oparciu o nowy rysunek protonu, na którym pokazane są wszystkie najistotniejsze elementy. Na rysunku mamy proton zaznaczonymi.
I will carry out further explanation based on the new proton drawing, which shows all the most important elements. The figure shows a proton with the gravitational field force lines marked. The window of the electrostatic field force lines emerging from the proton was also shown. The lines of force of the gravitational field form a funnel around the electrostatic window. The directions of the gravitational field force lines are opposite to the direction of the electrostatic field forces emanating from the proton. An electron will always be attracted by a proton and will always be found in a gravity funnel. A different position of the electron within the proton is impossible. The electron will stabilize when the electrostatic forces of the proton attracting the electron balance with the forces from the gravitational funnel trying to throw the electron out. The spinning motion of the proton will create a centrifugal force and the electron will be moved some distance from the proton. At the same time, the forces pushing the electron out of the gravity funnel will decrease because the distances from the funnel will increase. It is an automatic mechanism for positioning an electron relative to a proton.
Co dzieje się z elektronem, jeżeli wirowanie protonu jest zbyt szybkie, czyli zbyt wysoka temperatura? Elektron może opuścić zasięg oddziaływania protonu i stanie się wolnym elektronem.
What happens to the electron if the proton spin is too fast to high temperature? The electron can leave the range of the proton and become a free electron, and the proton will become ion. A special form of such matter is plasma, as it results from the considerations and the forces occurring within the protons. An electron can never fall onto a proton, regardless of whether the proton is spinning or stationary. Also, the spin or the immobility of the electron has no effect on its position within the proton. Let us also consider what the distribution will be electrons within an atom that contains more protons and more neutrons. In order to better understand the problems related to this topic, we need to explain some details in the pictures. The figure shows 4 adjacent nucleons. A loose space is created between them. We know that positrons and electrons alternate on the surface of nucleons.
Pozytony i elektrony na styku nukleonów tworzą bardzo silne wiązania pomiędzy nukleonami. W luźnej przestrzeni zaś pomiędzy pozytonami i elektronami tworzy się bardzo silne pole elektrostatyczne.
Positrons and electrons at the junction of nucleons form very strong bonds between nucleons. A very strong electrostatic field is created in the loose space between the positrons and the electrons. If other lines of force of the electrostatic field pass through such a strong field, they will be deflected and may also split. This statement is very important, because in the larger nucleus, the nucleons that make up the nucleus are arranged one on another in layers. The conclusion is that some of the electrostatic fields emanating from the protons outside the nucleus will be weakened and some will be enhanced. This has a significant relationship with the so-called electron shells K less than L less than M less than N less than O less than P less than Q, and subshells S, P, D, F, G, H, I, i.e. the spatial distribution of electrons around the atomic nucleus. In Fig. 1, 2 positive charges plus Q are placed and 2 lines of electrostatic forces are drawn on the axis of symmetry between these charges at some distance. A third charge with the value plus 2Q is drawn. The lines of force from charges plus Q deform symmetrically, 2 downwards and 2 upwards.
Kierunek tych linii sił został zmieniony o prawie 180 stopni w stosunku do pierwotnego. Na rysunku drugim przesunięto ładunek trzeci, oznaczony plus 2Q, o niewielką odległość w górę. Symetria została zdestabilizowana. Po takiej czynności jedna z linii sił...
The direction of these lines of force has been changed by almost 1,800 compared to the original. In Fig. 2, the third charged mark plus 2Q has been shifted by a small distance upwards. The symmetry has been destabilized. After doing so, one of the lines of force from the upper charge plus Q will go down. The electrostatic field directed upwards will be weakened and the field directed downwards will be enhanced. This is what happens with the field from protons closer to the center of the nucleus. A simplified example of this arrangement of electrons around the nucleus is shown in the figure. So the electrostatic field that surrounds the proton is slightly different than it would appear from distributed electrostatic windows of protons filling the atomic nucleus. Each proton shell in the nucleus corresponds to the basic orbits, if the nucleus is spinning, on which the electrons are located, i.e. K, L, M, etc., and the additional orbits S, P, D, etc. are subshells which arise as a result of the amplification or weakening of electrostatic fields from the electrostatic windows of the proton. For the same reasons, additional centers of electrostatic fields may arise in the orbits of atomic nuclei, especially elements that lack less than 4 electrons in an electron octet. Therefore, elements with only 1 electron missing from the octet are the most active of the nonmetals.
Różnice pomiędzy obowiązującym aktualnie kwantowym modelem atomu a modelem
Differences between the currently valid quantum model of the atom and the model according to the new theory of light is huge. NTW shows how energy is created from the union of nucleons. Shows that only matter can be the carrier of energy and that miracles such as the generation of energy from mass do not exist. I will provide a full description of the differences between the current theories in physics and the new theory of light in the last episode. This is where I end this episode. In the next one, I will continue the topic of interactions between matter and it will mainly concern the ejection of photons from the atom and the behavior of the atoms in the crystal.
atomów kryształu.
Thanks for your attention and please watch the next episode.
Do zobaczenia.
See you soon.